Today's lesson is on the dot product and angles between vectors. Okay, my learning objective for today is I can perform vector operations using scalar multiplication and vector additions, which includes addition of negative vectors. Okay, so when I have two vectors, the dot product, I show it with a filled-in circle. So this shows me that I am using the dot product. That is, I am going to take x1 times x2, and I'm going to add to it y1 times y2. And the result of the dot product is it's a scalar, and a scalar means it is a magnitude only. There's no direction with it. So that means it is not a vector. It is just a number. All right, so let's do an example of a dot product. If vector u is 3, -6, and vector v is 4, -2, find the dot product of vector u times vector v. Okay, so I am going to take, so here's x1, y1, x2, y2. So the dot product of u times v is 3 times 4 plus -6 times -2. So this is 12 plus 12, which is 24. So I have just a number. So I have a scalar. All right, let's find, I want to find the angle between two vectors. And my angle should be between 0 and 180 degrees. So to find the angle, I'm going to take the cosine inverse of the dot product divided by the magnitude of each vector. Okay, so let's get a visual of what this looks like. So I'm going to plot both of my vectors. So my vector u is 6, 4, 6, 1, 2, 3, 4. So this is vector u, and vector v is at -7, 2. Okay, and I am looking for, I want to find the angle between the two vectors. So I want to know what's this angle here. Okay, so I'm going to substitute into my formula. So this is the cosine of theta is the dot product. So this is going to be 6 times -7 plus 4 times 2. And then the magnitude of each vector. So the magnitude of vector u is 6 squared plus 4 squared times the square root of -7 quantity squared plus 2 squared. Okay, the biggest mistake I see is forgetting to put the negative number in parentheses when you raise it to a power. So this is the cosine inverse equals -0.648 So my angle is the cosine inverse of negative 0.648, which turns out to be about 130.365 degrees. Okay. So I can solve it this way, just substituting into the formula, or I could do it another way. So I'm going to just show you so you have more choices. Okay, so these are two right triangles. So this is side of 7 and the side of 2. And let's call this angle alpha. And this, if I block out into a right triangle, is 6 and 4. And let's call this angle beta. So if I add alpha, beta, and theta, they total 180. So if I find alpha and beta, I can subtract them from a 180 to end up with theta. So I can find alpha and beta. So I'm going to make this a little smaller so you can see which I'm. So I can find the angle by doing the tangent inverse. So alpha is the tangent inverse of y divided by x. So that's 2 divided by 7. So I get about 15.945 degrees. And solving for beta is the tangent inverse y divided by x. So 4 divided by 6 is 33.690. So to find theta, that can be 180 minus 15.945 minus 33.690. And that is 130.365. Okay, so I get the same answer. So substituting into the formula is the more abstract way that we're moving towards. Using plotting it and graphing it is just to get an idea what the equation represents. Okay, so next, I want to know if I have two parallel vectors or not. So if two lines are parallel, I know they have the same slope. So with parallel, a similar relationship exists for vectors. So if I have two vectors, and if y divided by x of the first vector equals y divided by x of the second vector, then the vectors are parallel. So I want to find some value a for my vector u and vector v to make these two parallel. So here this is going to be x1, y1, x2, and y2. So I'm just substituting into this equation. So y1 is negative 6, and x1 is 3, y2 is a, x2 is 4. So to solve for a, it is going to be 4 times negative 6, and I'm going to divide by 3. So 4 times negative 6 is 24, divided by 3 is negative 8. Okay, if vector u and vector v are perpendicular, then the angle between them is 90 degrees. And the slopes are opposite reciprocals. Okay. So when I have my two vectors u and v, if I'm perpendicular, then my dot product is 0. So find some value a so that my two vectors are perpendicular. So I'm going to set my dot product equal to 0. So x1 times y1. So 3 times 4. So x1 times x2 plus y1, negative 6 times y2, a equals 0. So I'm setting my dot product equal to 0. So this is 12 minus 6a equals 0. So 12 equals 6a, so a equals 2. Oops. So next, determine if u and v are parallel, perpendicular, or neither. So not parallel or not perpendicular. Okay, so first I want to check, do I have the same slopes? So negative 4 divided by 3 and 3 divided by 4. These are not equal, so I am not parallel. So next I want to check, are they opposite reciprocals? So I have one negative, one positive, and my numbers are flipped. So I am perpendicular because I have opposite reciprocals. Okay, 6. Given A is at 3, 6, B is at 7, negative 5, and C is at negative 4, 3. Find the measure of angle A. So these are not vectors, and I know that. They're points because of the symbols. I have parentheses, not those pointy brackets. So A is at 3, 6. So 3, 6. B is at 7, negative 5. 7, negative 5. And C is at negative 4, negative 3. Okay, so I'm trying to find the measure of angle A. Okay, so I'm going to set up and do this again both ways. So I can do this a couple ways. So I can do it a vector way or adding up 3 angles again. So this time I'm going to have my horizontal line right here. And if I box out my triangles here and here, I can do this. So I have alpha, theta, and beta again. So this one I count, this is 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And 1, 2, 3, 4, 4 here. Okay, so let's find alpha. Alpha is the tangent inverse. My pen's not right in here. Tangent inverse y divided by x. So 9 divided by 7. So I get 52.125 degrees. Beta would be the tangent inverse. Y divided by x is 11 divided by 4 is 70.015 degrees. So theta is 180 minus those two angles, minus 52.125 minus 70.015. So I get theta is 57.858 degrees. Okay, so this is assuming you have a graph available, but we're in a vector unit. So this is physically what this looks like. I'm interested in more the vector approach. So I know, and I can set up my vector AC here. So this is vector AC. So vector AC is from this triangle. I know that this is -7, -9, because I went left 7 and down 9. And vector AB, so I'm interested more in the vector approach here. So vector AB is going to be 4, -11, because I'm going down here. So this is going to be 4, -11. Okay, so I'm going to use the formula, which is the cosine of the dot product divided by the magnitude of each. So I'm going to say the cosine of theta. So this is going to be -7 times 4 plus -9 times -11. And I'm going to do the magnitude of each vector, which is -7 quantity squared plus -9 quantity squared times 4 squared plus -11 quantity squared. So I get the cosine of theta equals 0.532. So theta is the cosine inverse of 0.532, which is 57.858 degrees, which is what I got up here. So this is really the abstract way that we're working towards in this unit as a pre-calculus student. Okay, that's it.